My name is Joe Zwanziger. I'm a professor of chemistry at Dalhousie University. I'm cross-appointed into the physics department at Dalhousie. I'm a Tier 1 Canada Research Chair in NMR Studies of Materials. It's really critical for me to have access to large-scale computations. So the Compute Canada machines are terrific, and what's particularly terrific about them, I think, is the personnel support for scientists. So the administrative support of the machines is very, very good. I'm really interested in the problem of how the optical properties of glass change due to its environment, and in particular, the environment of stress on the glass. And that really means physical pressure, pushing on the glass, how that will change its optical response. So we got into this whole game because the zero-stress optic glass that is sold commercially now has a very high lead content. And various legislations across the world, or regulations, forbid the use of lead in all sorts of consumer products. And so various industries are looking for ways of understanding why lead has the properties it does and what, if anything, they could replace it with. So that's the problem that we actually solved. On the computer, we can screen many different glass additives or compositions of glass that we could, in principle, make in the lab, but we can do it so much faster, and we can do it in so much more depth on the computer. And some of the glasses that we want to understand are glasses that I would really hate to have to make in the lab because they contain very toxic elements like mercury. So we don't want to make glass out of mercury, but we need to understand how it would act if we did, because that points us in the way of replacing other elements in the glass. What we did was find the trend across the periodic table of elements for how the property of stress optic response is conferred to a glass. And we did that all on a computer. The amount of computing cycles that we can get access to are enough to begin to solve problems large enough to have interesting answers. It's very important that we keep expanding that resource.